Okay, this is not going to be some sci-fi review, alright? Not yet. But this is about something real, something interesting across the universe and with a little dark tinge to it. Yep, it's going to be fun, as long as we'll be talking about dark matter. And the latest discovery about dark matter is going to make it far better, so why wait? Let's get straight into it, yeah? If some of you guys are unfamiliar with the term dark matter, you can basically put it as, if physicists ever had a most wanted list, these so-called dark matter particles would be right at the top. Why? Well, that's some technical stuff we're going to step into. Anyway, don't worry, we won't make it hard. So basically, dark matter is an unseen substance that exists throughout the universe. In fact, it accounts for about 85% of all matter in the universe. Dark matter, unlike typical stuff within you, your computer, the planet, and all the stars in the sky, do not create or reflect light. In fact, for decades, physicists have attempted to identify the particles that comprise this puzzling material, but thus far, all searches have turned up nothing. You may say, wait a minute, how do we know dark matter exists if it's invisible? Well, that's where gravity lights up the scene. Dark matter can be detected due to the gravitational pull it has on visible things. This is comparable to how you can determine whether it's windy outside without seeing the wind, right? So that's the preliminary lesson we needed. How about we turn towards the juice? So the recent discovery was about how dark matter could be measured in the solar system. Of course, we need to measure such a material, right? So exactly how can it be done? Let's see. To understand this, we've got to see where you can experience this force, and that's got to be on a spacecraft, right? So the new theories indicate that the gravity of dark matter interacts very minimally with all the spacecraft that NASA has deployed on routes that go out of the solar system. If a spacecraft travels through dark matter for a long enough period of time, its trajectories are altered, which is vital to consider when planning missions for specific future missions. The retired Pioneer 10 and 11 probes, which launched in 1972 and 1973 respectively, the Voyager 1 and 2 probes, which have been exploring for more than 40 years and have entered interstellar space, and the New Horizons spacecraft, which was flown by Pluto and Arrokoth in the Kuiper Belt, are examples of such spacecraft. So you have an example to test on. However, it has just a slight effect. Due to the impact of dark matter, the course of a spacecraft like Pioneer 10 would only alter by roughly 5 feet after traversing billions of kilometers. They do sense the influence of dark matter, but it's so little that we cannot measure it. So the next thing is, where does the galactic force take over? Okay, at a certain distance from the Sun, the galactic force becomes stronger than the Sun's attraction, which is formed of ordinary stuff. According to Belbruno and Green, this transition occurs at about 30,000 astronomical units, or 30,000 times the distance between the Earth and the Sun. That is well beyond Pluto's reach, but still within the Oort cloud, a swarm of millions of comets that surrounds the solar system and reaches out beyond 100,000 astronomical units. This tells us that the gravity of dark matter might have influenced the track of things like Oumuamua. By the way, do you guys remember the headlines which were filled about the cigar-shaped comet, the asteroid that travelled through the inner solar system in 2017? Well, dark matter might have an answer to it. Its extraordinary high speed might be explained by the gravity of dark matter pulling it over millions of years. Of course, that wouldn't be an ordinary thing. So if there were a large planet in the solar system out of reaches, such as Planet 9 or Planet X, which astronomers have been looking for in recent years, dark matter would impact its orbit as well. If this planet exists, dark matter may be able to push it away from the location where scientists are now searching for it. Some of the Oort cloud comets might have escaped the Sun's orbit entirely due to dark matter. So when physicists first started on the topic, they just had this question: can such a thing ever be measured? We can't have a spacecraft travel that far, right? But there was an answer to this tool. Basically, a spacecraft would not have to go that far to measure the impact of dark matter in the solar system. At a distance of 100 astronomical units, a spacecraft equipped with the approximate experiment might assist astronomers in directly measuring the influence of dark matter. A spacecraft outfitted with radioisotope power, which has allowed Pioneer 10 and 11, the Voyagers and New Horizons to go extremely far from the Sun, may be able to conduct this measurement. A spaceship of this type may carry a reflecting ball and drop it at a suitable distance. The ball would simply feel galactic forces, whereas the spaceship would sense thermal forces from decaying radioactive elements in its power system in addition to galactic forces. After removing the thermal force, researchers could examine how the galactic force corresponds to variations in the paths of the ball and the spaceship. The deviations would be monitored using a laser while the two items flew parallel to each other. One candidate for such an experiment is the Interstellar Probe mission idea, which intends to go around 500 astronomical units from the Sun to examine that unexplored region. Wait a second, did I make that sound simple? Well, that's not how it's supposed to be though. Dark matter was first proposed as a hidden mass in galaxies in the 1930s. Yes, the earliest indications that dark matter exists appeared in the 1930s, when an astronomer named Fritz Zwicky looked at a faraway swarm of galaxies. He noticed something strange. The galaxies were traveling quickly. They were traveling so quickly that the galaxy cluster was about to split apart. So there has to be something invisible among the galaxies holding the cluster together with gravity, right? Also, astronomer Vera Rubin discovered in the 1970s that stars swirl around spiral galaxies considerably faster than predicted. These stars should collide at such high speeds. Galaxies must be kept together by the gravity of dark matter to avoid tearing. Okay, now what do you think about dark matter? Quite an interesting field of study, huh? Astronomers will discover more about dark matter in the universe thanks to the latest generation of cutting-edge telescopes. The James Webb Space Telescope, which launched on December 25th, 2021, will help us understand dark matter by capturing photographs and other data of galaxies and monitoring their lensing effects. We can't miss out on other opportunities too. The Nancy Grace Roman Space Telescope, which is scheduled to launch in the mid-2020s, will undertake surveys of over 1 billion galaxies to examine the impact of dark matter on their forms and distributions. Yes, 1 billion. The European Space Agency's next Euclid project, which will include a NASA contribution, will also seek dark matter and dark energy, going back roughly 10 billion years to a time when dark energy began hastening the expansion of the universe. And the Vera C. Rubin Observatory, which is now under construction in Chile and is a cooperation of the National Science Foundation, the Department of Energy and others, will provide crucial data on this conundrum of dark matter's fundamental character. However, these sophisticated techniques are meant to search for dark matter's significant impacts across long distances and well beyond our solar system, where dark matter's influence is considerably weaker. Sending a spaceship out there to detect it would be a massive discovery, right? Another interesting stuff among these is dark energy. If the universe is simply made up of galaxies, stars, planets, and other known objects, it should not be expanding. There is something more out there. There must be energy causing the cosmos to grow. We don't understand what this energy is. We have no idea where it originates from, but we can see it's there. The energy has been dubbed dark energy by scientists. Dark energy accounts for 68% or roughly 2/3 of the cosmos. Dark energy and dark matter account for 95% of the cosmos. That's basically everything. That leaves only a tiny 5% for all the matter and energy we know and comprehend. Light, heat, and X-rays, together with a substance such as humans, elephants, planet Earth, the Sun, and all galaxies, account for only 5% of the universe. That's not a lot. We don't know what most of the cosmos is comprised of, which may come as a surprise. We honestly don't. But of course we do. You could say it's made up of galaxies, stars, planets, black holes, and everything else in space. But we know things like dark matter exist. We've got a lot to learn. Perhaps humans are too little a subject in comparison to the enormity of our cosmos. Well, this isn't the end. More exciting material will pop up in the following days, and we'll be here to bring you the best of it. Meanwhile, do you guys want to know more about what the James Webb is clicking now on its mission? Well, you got to. Yes, the James Webb Telescope has clicked 7 shocking new images, and that's going to bring up more questions in your head. But you guys know where to peep in for the answers, right? Yeah, right here. So do check out our latest episode on the James Webb Telescope. Anyways, that's all we've got for today. Make sure to subscribe to our channel if you want to see more videos like this one. And while you're at it, enable the notification bell so you don't miss any of our future uploads. We hope you had a great time watching the video, and we'll see you again at the next one.